Hey guys, today we'll be going over significant figures, which are also referred to as sig figs. So, what are sig figs? Sig figs are important numbers in a measurement that tell us how precise or accurate it is. Remember those key words. So, here's some sig figs rules that I have listed. Non-zero numbers are always significant. Non-zero numbers are always significant. So in my example, I have 45. Both of these numbers are non-zeros, so they are both significant. Zeros between non-zero numbers are always significant. What does that mean? In my example, we have 305. The zero between 3 and 5 is significant because it's surrounded by two numbers that are not zeros. So 305 will have 3 sig figs. Zeros to the left of all non-zero spaces are never significant. Here in my example we have a bunch of numbers before 95, but we can see that 95 is kind of at the end, right? So it only has 2 sig figs because these numbers are all leading zeros. Trailing zeros in a number with a decimal point are significant. So for this we have 2.00. These zeros after the 2 count because there's a decimal place right there. So this example has 3 significant figures. So here's a little chart I made for you guys. Let's go over everything that's in the chart. Numbers between 1 or 9 are significant. What does that mean? We can see 44.2. Since these numbers are between 9 to 5, they're all significant. So we have 3 sig figs. Trapped zero. Trapped zero means the zero that is trapped basically in the middle. It is also significant. 30002 has 5 sig figs because the zeros in the middle are surrounded by non-zero numbers. Leading zeros are not significant. In my example here, I have 0.000029. The numbers that come before the 2, which is the first non-zero numbers, are not significant. So this only has 2 sig figs. Trailing zeros. There's 2 kinds. So trailing zeros are not significant, but if they have a decimal place, then they will be significant, like 2.200 has 4 sig figs. But instead of a decimal, if we put a comma there, the zeros that follow the non-zero number are not significant. So this only has 1 sig fig. So in the next slide, we'll practice some of these together. So we have, let's look at this number first. 0.00456, right? So this number will have 3 significant figures because the leading zeros, they don't count in the measurement, okay? So in this one, we have 1002. For this one, we would have 4 sig figs because the zeros that are trapped count, like we have here. So we have 0.00456 0.00780. This has three significs because the leading zeros, once again, they don't count. We have 9.0.0.0.0. For this one, we only have one significant figure because there's no decimal point here, right? We don't see a decimal point. So this one only have one significant figures. So we have 3.2.0.1.0. This has five significant figures because the zero is between two non-zeros and the other zero is behind the decimal, so it counts. In the next example, I have 0.0000205. For this one, we will only have three significs because the leading zeros once again don't count. In the next slide, I'll have you guys try some of these on your own. Okay, let's go over the answers.